Hello, this is Mr. Rasmussen with Algebra 1, Lesson 99. And in this lesson, we get our third scenario for distance problems. So let's review the first two. The first scenario was where you had two distances equal to each other. Either you went somewhere and then came back, and henceforth a rate and time is equal to a rate and time. The second scenario is where you had two distances added together equal to a total amount that they gave you in the question. So like you walked for a little bit and then you got a ride and the whole trip was, 20 miles. The third scenario today in this lesson is where you have two people going on the same trip, similar to the first one here, but one either has a head start or at the end of where you're recording what happened, one is further than the other. And that looks two ways. It can look like this, where there's a certain amount here, the one person's ahead, or it can look like a head start, where the first person is already down the course before the second person starts. And the way that looks as far as our equation is going to be a distance plus a certain amount is equal to the other distance. So obviously the other distance is the largest one. This one plus the amount is the shorter distance, and you got to make up the difference. So rate and time plus that amount is equal to the other rate and time. Let's jump into example 1 here and see how we do this. We have at 8 p.m. Archimedes left camp and headed south at 20 kilometers per hour. At 10 p.m., Patroklos headed south from the same camp. If Patroklos was 50 kilometers ahead of Achilles by 3 a.m., what was his speed? Okay, so let's put our scenario in here. We got the rate and time plus, it says that Patroklos was 50 kilometers ahead. As soon as you hear something like that, it puts you into scenario 3 here. Okay, so which one is faster? Which one went farther? That'd be Patroklos, so he has the larger distance, and so the P's for subscripts there go for him, and I'll put A's over here for Archimedes. All right, then what other information do we know? Well, we know some times. So if Archimedes left at 8 p.m. and then it was recorded at 3 a.m., that would be a time of 7 hours. So let's put that in there. And so rate of Archimedes plus 50, plug that in there, okay? And I'll back up here a little bit. We're also told how fast Achilles is going. He's going 20 kilometers per hour, so let's put that in there. And then we don't know the rate of Patroklos, but we do know his time. He left at 10, recorded at 3 a.m., that would be 5 hours. Okay, once I put all my information in there, then at this point, it is just solving it. So 7 times 20 is 140, plus 50 is 190, is equal to 5 times the rate of Patroklos. Oh boy, I am messing that up. There we go, 5. Let's divide both sides by 5, and it looks like, well, I'll double check my answer there. 38. And what's our units? Our units is kilometers per hour. All right, 38 kilometers per hour. So the biggest part to this lesson is just getting it set up correctly. All right, let's look at example 2. We have Rachel has a 15-kilometer head start on Charlene. How long will it take Charlene to catch Rachel if Rachel travels at 70 kilometers per hour and Charlene travels at 100 kilometers per hour? So this one here looks like they're both starting out, and then we've got Rachel, there's Rachel, has a head start on Charlene, but then they asked how long will it take for Charlene to catch her. So it looks like this here. All right, let's set up our equation. So we got RT plus a certain amount. That certain amount is the head start, which is 15 kilometers, equals the other rate and time. Who is faster? Who goes the larger distance in our scenario between these two arrows? It's going to be Charlene, so she gets the C's, and Rachel is in the first part there. All right, what other information do we have? It says, how long will it take Charlene to catch Rachel? Rachel's traveling at a rate of 70 kilometers per hour, and Charlene is traveling at a rate of 100, so we'll put that there. And then, a little tricky in this question, we're looking at the two arrows, and Rachel's here, Charlene's here, and they both run and catch each other. The times are actually the same. The time of Rachel is equal to the time of Charlene. The times are actually going to be the exact same for both of them. Though they don't actually stay that, you got to kind of figure that out in the way they're setting up the scenario. So we can substitute anyone for anyone. So I'm going to keep the TR and substitute the TRN for the TC there. Okay, so let's work on our math here. Subtract 70 TR from both sides, and it looks like we get 30 TR. 15 divide by 30 divide by 30. That reduces to 1/2. It takes half an hour for Charlene to catch Rachel in whatever situation of movement that they are in. Okay, I hope that makes sense there on how to set it up. Go ahead and do the practice problems, and then you can check your work with my work. So here we go. Practice problem A. We have at 5 a.m. Napoleon headed south from Waterloo at 4 kilometers per hour. At 7 a.m. Wellington headed south from Waterloo. If Wellington passed Napoleon and was 20 kilometers ahead of Napoleon at 2 p.m., how fast was Wellington going? So, what's the scenario here? They both leave the same spot. However, here's Napoleon and here's Wellington. Wellington passed him up, and there's a certain amount being that he is ahead of him. All right, so rate and time of Napoleon plus certain amount is equal to the rate and time of Wellington. Well, let's put some information in there. We don't, well, Napoleon was heading 4 kilometers per hour, so put 4 in. Napoleon started at 5 a.m. and we took the information at 2 p.m. So we got to get 5 to 12, noon, which is 7 hours, then add the 2. So he's traveling 9 hours. What's the difference between them? It's 20 kilometers is how far ahead Wellington is. We don't know Wellington's rate, that's what we're trying to find out, but we do know his time. He left at 7 a.m., so we're looking at 7 hours there. Okay, 4 times 9, put that in there, 36 plus 20, we got 56 right here is equal to 7 RW, divide by 7, and it looks like the rate of Wellington is 8 kilometers per hour. All right, practice problem B. Helen has 4 kilometer head start on Paris. How long will it take Paris to catch Helen if Helen travels at 6 kilometers per hour and Paris travels at 8 kilometers per hour? Okay, so this scenario here, somebody has a head start, so the number comes first, looks like this. Helen has the head start, but then you can see Paris is going faster and travels a little longer to catch her. All right, so rate and time plus a certain amount equals rate and time. This one is the P here because Paris traveled further, so this rate and time is H. That'd be one mistake to make, is get them switched. That'll get you a wrong answer. All right, Helen has a 4 kilometer head start, so plus 4 goes in there. How long will it take Paris to catch Helen if Helen's traveling at 6 kilometers per hour? So rate Helen, and the time of Helen I'll put there. Once again, the times are the same because they're starting, one's starting here and one's starting here, and they catch each other. The time it's taken them to do both of those distances is the same. So Paris travels at 8 kilometers per hour. Put that there, and we'll substitute the time of Helen in for the time of Paris. Even though we're trying to, well, let's do it the other way, because we're trying to find out how long it takes Paris to catch her, even though it's the same time. All right, so we'll put the P's in there for Paris. All right, let's subtract 2t from, or 6t from both sides. We get 4 equals 2 time of Paris, divide by 2, divide by 2. It looks like it's going to take Paris 2 hours to be able to catch up. And that's our answer for practice problem B. Okay, please feel free to text me, contact me if you need some assistance with this, and have a great day.